Engine Performance 1, Test 2. And this is chapters 3 and 4. The diameter of a cylinder, I'm talking about a cylinder would be on an engine, is called the... Yeah, that's right. Y'all are smart. Which of the following is the most correct statement about the direction of engine rotation? Now, that's a good question, isn't it? A, most engines rotate counterclockwise as viewed from the front. B, most engines rotate counterclockwise as viewed from the non-principal end of the engine. C, most engines rotate counterclockwise as viewed from the principal end of the engine. D, most engines rotate clockwise as viewed from the front of the engine. Is that crazy or what? If you're looking at the front of the engine, if it's in a car like the one that the Nissan, which way does the engine turn that you're working on, Harley? Clockwise, yeah. And under what circumstances would an engine turn counterclockwise? And when you say the front of the engine, I'm talking about where the belts are.
When you're looking at it from the other side?
No, actually no. If the belts, you know, haven't you seen cars like Mitsubishis and some of the Honda Civics and all, that the engine is in there backwards and the transmission's on the passenger side and the timing belt's on the driver's side? Haven't you seen those?
Yeah.
Yeah. That is actually, those turn backwards. They have to. They're going to turn the same way the car rolls. Or you're going to have 4 reverse gears. You know what I'm saying? Keep that in mind. They're not always, I wanted to say that because sometimes you'll fall in a trap. If you're thinking, all engines turn this way. Nuh-uh. Not if you're walking up to the driver's side of the car and you're looking at the belts, it turns the opposite way. That's the way that is. Some of the industrial engines, you can change if you change the timing marks, put different timing marks that lined up on the camshaft, you can run the engine backwards as opposed, or forwards. Either way you go, you've got to change the starter and whatnot. You know, but anyway, that's, never mind, whatever. Number 2, if you're going to go by number 2, that's D. The following statements are all correct except, and this is an ASE style question, A, torque is the measurement of rotational force. B, torque is often expressed in pound-feet. C, torque always results in movement. D, all of the above answers are correct. That's actually C. Torque does not always result in movement. Anybody that has put a wrench on a bolt and tried to turn it and recognized that the bolt did not turn because you didn't, you know, have enough lead in the seat of your pants or whatever, you know that you can put torque on something without turning it, right? Do you run into that problem a lot, Brian? I just like to watch his reaction there. All right, let me see here. Technician A says changing connecting rod length changes engine stroke. Technician B says changing connecting rod length changes the position of the piston in the cylinder. For the ones of you that don't know, this is a connecting rod, right? This is the piston. This is the diameter of the piston, you know. All right, so if I change the length of this connecting rod, am I going to change what we're talking about here, whatever it was? Changing the connecting rod length changes engine stroke, does it?
Yeah.
Does it? You better be thinking clearly. Some of you guys work on race cars. If I change the connecting, if I want to change the stroke, am I going to change the rod?
Change the crankshaft, won't you?
Crankshaft. You're not going to change the stroke by changing the rod. You'll change the position of the cylinder, piston in the cylinder, but the stroke's going to be the same. Got it? Think about it.
Yeah.
I mean, the crankshaft is how you do that, right? So number 4 is basically going to be B, which says technician B says changing the connecting rod length changes the position of the piston in the cylinder. All of these are correct except what? A, engines produce higher horsepower at higher altitude. B, forced induction reduces the effect of altitude on engine power. C, engines produce lower horsepower at higher altitude. And D, air is less dense and contains less oxygen at higher altitude.
A.
That's A. What? Yeah, except. See there? You look at those, you'll fall in a trap. And so basically, how many of you have ever driven a vehicle, I mean particularly one with a carburetor on it, at a high altitude? And it runs terrible. It will hardly pull your hat off. And you're thinking, what in the world is wrong with my car? It's just bad. You know, it just runs awful. What you got to do if you're going to, huh?
You got to put some kit on there.
Well, what you got to do is you got to advance the ignition timing, and you got to change the fuel mixture and all that. So basically, there's a couple other things you got to be done. Let me see. The blank converts linear motion of the pistons into rotary motion. Linear motion of the pistons means they go up and down, right?
Crankshaft.
Crankshaft does that. The crankshaft is round. I mean, it goes round and round, and it needs to go round and round because everything is round. The wheels are round, the drive shaft is round, the gears are round, transmission parts are round. Everything's round, so it's got to go round and round. That's the way I always think of it. How many degrees of crankshaft rotation are needed to complete the four-stroke combustion cycle?
720.
720 degrees. That is 2 full turns of the crankshaft. And the way you're looking at cubic inch displacement or liters or whatever, if you can catch every last little bit of the air that thing is capable of pumping, you know, in other words, if it's got perfect 100% volumetric efficiency, every time it makes 2 full turns, a 3-liter engine is moving 3 liters of air. If it's turbocharged or something, it'll be more than that. If it's not, it'll be less than that. But 3 liter is the displacement. All right, how many degrees of crankshaft rotation are required for a piston to travel from top dead center to bottom dead center and return to top dead center?
360.
Yeah, that's basically, and that's what is, how many strokes is that? How many strokes is that? Top dead center, you know, this right here would be, if the crankshaft's coming up, right there is top dead center, that's bottom dead center. Top dead center, bottom dead center. So how many strokes is it?
2.
That's 2 strokes. There's 4 of those, right? Okay, an 8-cylinder engine with a bore of 4 inches and a stroke of 3 inches has a displacement of what? Ooh, what do you think about that? Number 9. You guys do the math on that? An 8-cylinder engine with a bore of 4 inches and a stroke of 3 inches. Let me ask you this before we go into the cubic inches of it. Is that over square or under square? That's going to be over square because you got a bigger bore than you do a stroke. Actually, it's going to be A on this one. 302 is what it is. Because, you know, think about a 350 is more or less 4x4. It's like a square engine and all that pretty much. I mean, you could, you know, it's really close, you know, and some of them.
How do you do the math on that?
It's very, yeah,
Or-
a bunch of numbers.
Really,
Yeah.
the math is a bunch of numbers?
Yeah.
I
It's
had
like,
no idea.
Yeah. Well, basically, what you gotta do is you gotta get the volume of each cylinder. You know what I mean? You basically got to do use pi to get the volume of each cylinder, and you got to multiply that by how many cylinders you got. That's how you basically do that. Incidentally, here's another thing. What if I told you I had, let's say, a 6-liter engine? How many cubic inches is that? Ballpark figure.
4.6.
How many cubic inches per liter? You can figure it out. What is a 302 in liters?
302.
50. 5 liters. So 5 into 300 is just under 61 inches, cubic inches, about 61 cubic inches per liter. So if it's a 6 liter, 6 times 6 is 36, so that'd be 366, right? You
There's a
got that?
question. Do they round up with the cubic inches?
Yeah, usually if they want it to sound like a bigger engine. I mean, they play with numbers like that all the time. But like for instance, a 4.9 liter is a 306. You know, and a 5 liter is a 302. 306 is a straight 6. You know, so you can figure it out. I mean, it takes the 2 that you know. It's kind of like the Rosetta Stone or whatever. An engine with a displacement of 302 cubic inches converts to how many liters rounded off? That's where I was at with that one. 4.9. Actually, this one right here, they're going to round it off, but the 300 in a Ford pickup, they say it's a 300, and they call it a 4.9. But a 5.0, see what I'm saying? That's crazy. They get you all hooked up?
Yes, sir.
All right. Chill out for a second. We're going through a test. You can find you a chair or something. Find you a seat. Somebody find him a seat. Go over and find you a chair somewhere. All right. Okay, the ratio of the volume of a cylinder with a piston at bottom dead center to the volume of the cylinder with a piston at top dead center. What's that known as?
Compression ratio?
Compression ratio, that's right. What's the compression ratio, more or less, on a gas burner? Like 9, 10 to 1, 8 to 1, something like that. On a diesel, it'd be like 18 to 20 to 1. Those diesel have a lot more compression. 5.7 liter engines, about what size in cubic inches?
350.
Yeah, it's going to be about 350. The metric unit for torque used by most original equipment manufacturers is which of these? Newton meter, kilogram meter, foot pound, pound foot.
Foot-pound.
For Newton.
OEM. Believe it or not, if you look at nowadays, it's Newton meters. And we got a conversion calculator that's built into all data that'll help you with that, by the way, if you want to know any Newton meters things are. There was a time in the years gone by when I remember the days in the old shop manuals when just about every on American cars they would always put foot pounds, which the right way to say that is pound feet, believe it or not. You can look at that snap-on torque wrench, and right there under the little scale it says pound feet, which sounds dumb. You know, I mean, if you go around talking about pound feet, all these other mechanics will laugh at you. But I mean, that's basically the right way to say it. But they used to just put foot pounds or inch pounds, and then they started putting foot pounds or inch pounds, and in parentheses they'd put Newton meters, or you know whatever that would be metric. And then they started putting the metric scale outside the parentheses and the foot pounds inside the parentheses. You know, they're basically shoving foot pounds to the back. You know. All right, let me see. What's the chemical energy in fuel is converted to heat by burning the fuel at a controlled rate, and that process is called,
Combustion.
that's not complicated, combustion. How does a turbocharger increase engine power?
Forcing air mixture.
Yeah, it basically is shoving it down its throat. That gives you more than 100% volumetric efficiency. Which part of the four-cycle? Incidentally, I got a. Most of you guys probably don't know about it, but you can drive a vehicle that's not running quite right. And I have got a. If you look at the numbers on your scan tool, you get your mass airflow and your speed. I mean, your engine speed and all this, and you can actually put those into a calculator that I've got that I downloaded, and it'll tell you what the volumetric efficiency of that engine is, which is pretty cool if you want numbers to look at. And you can say, I know this engine's not breathing like it should because based on my mass airflow and the engine speed, my volumetric efficiency is lower than it should be. That way you're looking at air intake issues, exhaust clogging, and all this kind of thing. Let me see. Which part of the four-stroke cycle is illustrated in this drawing? Everybody knows that. What? And we're turning, look at the red arrow is basically, which one is it? Who said something?
Exhaust.
Yeah, because it's going up and the exhaust port's open. Very good. That's sharp. All right, let's throw this over there. In this drawing, which item is the camshaft? That's not too complicated.
Eggs.
Seriously? Which item is the camshaft? That's actually going to be C. High pressure common rail fuel injectors are opened by what? And what's common rail mean anyway? They're all getting their fuel out of the same rail. The pressure is high all the way across that rail, and they are actually not opened by pump pressure, but they can be opened by either solenoids or engine oil pressure, technically, depending on the engine. Accelerator pedal position sensor sends what kind of a signal to the engine control computer? That's a voltage signal. And which of these tools is used for checking a diesel injector nozzle for a proper spray pattern? See, we're forging into the diesel area right now. Pop tester. Basically, when the pressure comes to a certain place, and it's basically acting on the bottom of that little pintle, and it raises it against its spring, and then is able to spray fuel out. And using a pop tester, you got a gauge on there, and so basically you pull on a lever that's got a positive displacement piston, and then you watch the pressure go up, 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 up. Then when it goes, you know, again, it sprays, you'll know what the pop pressure is. And pop pressure test is what you check, one of the ways you test injectors. But specifications for diesel fuel include pour point, cloud point, flash point, all of the above. All of the above. Diesel fuel should be rated at what cetane rating? That's going to be C45 to 50. Cetane is a clear colorless liquid that has perfect combustion qualities, and they compare diesel to it to see how it compares. Basically, it's rated at 100. Basically, ultra low sulfur diesel fuel has how much sulfur content? Anybody know? 15 parts per million. The specific gravity of diesel fuel is measured in what units? That's crazy. API gravity. I don't know how you know that. American Petroleum Institute gravity. I always think of specific gravity as, you know, thinking about water or something. Which of these takes place during regeneration in a diesel particulate filter? Number 25, that soot is being burned. It gets rid of the soot. How many of you guys ever use a self-cleaning oven? You crank that thing up, it goes up to like 500-600 degrees, and whenever you open it up, it looks like a brand new oven, right?
Mm-hmm.
I mean, that's just,
I just did that yesterday, actually.
yeah. And I've always been kind of spooked about that, because if the thing's old and the seal's not good, it seems like it set the house on fire. Diesel exhaust fluid is injected where? These are good questions, aren't they? After the oxidation catalyst. And selective catalytic reduction uses urea injection to reduce what kind of emissions, and that would be NOx. Technician A says diesel engines can be tested using a scan tool to determine sensor values. Nowadays they can. Technician B says glow plugs can be used to locate a weak cylinder. C. Do you suppose maybe you could measure the resistance of a glow plug and determine which cylinder is not firing because of the heat factor?
Yes.
Resistance and all that, yeah. I also like to use my forward-looking infrared camera. Put it in there. The diesel engine is, this diesel engine here is what kind do you have there? What kind of diesel engine is that? Did you see in that picture? Anybody know? Number 29 is B, that's indirect injected, and then the next one is direct injected. Number 30 is direct injected, which is what the electronic diesels are typically all direct injected engines. Okay, anybody got any questions or comments about that?